We're going to complete a few more scientific notation multiplication problems, and then I'll show you how we do with division. So we're going to multiply 2.32 multiplied by 4. We can reorder according to the commutative property of multiplication because all of these numbers are separated by multiplication. And then I'm going to multiply that by 10 to the negative 6 times 10 to the negative 5th. And then when I take 2.32 and I multiply it by 4, I get 9.28. When the bases are the same, you add the exponents. So this is going to become 10 to the negative 11th. And I only have one number in front of the decimal, so this is already in scientific notation. So that is the result of multiplying this number by this number. And number 5, 7.1, I multiply by 6.7. And the result of that is 47.57. Then we're going to multiply those two numbers by 10 to the negative 5th times 10 to the negative 6. And once again, when the bases are the same, they both have a base of 10, you add the exponents. So this is 10 to the negative 11th. In this case, when you multiply 7.1 times 6.7, we get a number that has two values in front of the decimal. So we have the ones place and the tens place in front of the decimal, and we're only allowed to have something in ones place. So what we're going to do is we're going to move this decimal to the left ones, and we basically decrease this by one place. So over here, we need to increase this by 1. So our final result is 4.757 times 10, oh, that's a terrible 10, times 10 to the negative 10th. And that's your final result. Instead of using this little trick where you decrease the decimal or you decrease the place by 1 and you do the opposite on the other side, you could instead just write 47.57 times 10 to the negative 11th. And I could just change this to standard form. So I could move the decimal 1 time, 2 times, 1 time, 2 times, 3 times, 4, 5, 6, 7, 8, 9, 10, 11. Now if I moved it 2 places, then I'd have 9 places left for 0, so I'd have 9 zeros left. And make sure I have the right amount of zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. From there, 1, 2, 3, 4, 5, 6, 7, 8, 9. You could then back it up and change it back from standard notation to scientific notation, but do the scientific notation properly this time. And you'd move it once. I'm having issues with this marker. Let me try that again. You move it once, twice, 3 times, 4 times, 5 times, 6 times, 7 times, 8 times, 9 times, 10 times. So it'd be 4.757 times 10 to the negative 10th. I think that after watching me do that with all the zeros and then, you know, moving it this way and then moving it the other way and then finally getting this, hopefully you can see that this method where you decrease by 1 and then you do the opposite over here, you increase by 1, hopefully you'll see that that's actually going to be a faster method. So if you want to use that method, great. If you would rather write out the standard notation and then change it back to scientific notation, that is just fine by me. Now let's look at some division problems. So we have to go to the end of this. All right, number 7. We complete these in a similar manner to the multiplication. What we do is we separate the parts of the problem. So I'm going to take 7.1 and I'm going to divide it by 8.2. So 7.1 divided by 8.2. and I'm going to get 0.865, 853, etc. And I'm just going to go ahead and round that number. And then we look at the second part, and we're going to multiply this times 10 to the power of 5. Because when the bases are the same and you have a fraction, or when you're dividing, you subtract the exponents. We're going to get a power of 5. In this case, we divided and we got a smaller number. And so what we're going to do is we need to change this to scientific notation at the end. So we increase this by one place. We're going from 0.8659 to 8.659. So we had an increase in the size of the number when you're just looking simply at this number. If we had an increase over here by 1, we need to decrease this by 1. So the final result is 8.659 multiplied by 10 to the 4th power. Let's look at another division problem. All right, number 9. 4 divided by 3.63. We get 1.10, and that number goes on forever. It's an irrational number. And then you multiply that by 10 to the power of, and what we do is we subtract the exponents. So I'm going to put in parentheses 4 and negative 4, and then I take the numerator's exponent and I subtract the denominator's exponent. So this is really 10 to the power of 4 plus 4, because we had two negative symbols here. So 4 plus 4, we get 10 to the 8th power. And this is in scientific notation. So your final answer for number 9 is 1.10 times 10 to the 8th power. All right, let's move on to number 11. All right, number 11, 8.42 divided by 5. We get 1.684. And then we take 10 to the 3rd divided by 10 to the 2nd. So the numerator's exponent minus the denominator's exponent. We get 10 to the power of 1. And in front of the decimal, there's only one number, so it's already in scientific notation. So in number 11, you should have 1.684 times 10 to the 1st power. When we multiply and when we divide, we can use these shortcuts that I'm teaching you now. However, when you are going to add or subtract using scientific notation, I would prefer that you just add them in standard form. So you have them in scientific notation, you would change them to standard form, and then you would add or subtract. When you look at scientific notation, multiplication, division, we're going to use our rules. What you're supposed to focus on in 8th grade is multiplying and dividing using scientific notation. So those are the methods where you should have some shortcuts and know how to do those problems. Let's go ahead and look at number 13. It's a little bit more challenging. This involves multiplication. And we have this exponent here. What we're going to do is we're just going to look at our basic form, what we normally do, and we're going to take 8.9 times 10 to the 5th, and that's to the 4th power. So that's basically like writing out 8.9 times 10 to the 5th 4 times. Okay, so let's multiply 8.9 times 8.9 times 8.9 times 8.9. So 8.9 to the 4th power would be 6,274.2241. And then when the bases are the same and you're multiplying, you add them up. So 5 plus 5 is 10, plus 5 is 15, plus 5 is 20. And then we need to move this decimal to the left 1, 2, 3 times. So we decrease this number by, not 1, sorry, 3 places. So that means that we're going to increase this number by 3. So we get 6.274221, and you can round that if you want to, times 10 to the 23rd power. So for number 13, you should have gotten 6.274 times 10 to the 23rd. If you have any questions, we'll go over that in class, but hopefully this gave you a basic understanding of how to multiply and divide using scientific notation.